All right, hello. So here it is, 3.6, graph of functions. So vertical line test, I talked about this from last lecture, but let me recap this for you again. Recall functions. We say that a relation is a function if the order pair xy is a solution of a linear equation, right? And for every x, you only have one y, right? So that means x cannot be repeated. So in order to be something to be a function, something is called to be a function, the x value cannot be repeated. Okay. So for example, I have the equation y equal 2x minus 3 right here. And here's the graph of the function y equal 2x minus 3, right? So what I can do is in order to construct this line, I can make a t-table, right? So a t-table here. You don't have to write this down. Oops. Try to make it straight as I can. And then you pick the x value. So for example, when x equal 0, y is -3, right? When x equals 0, or you can eyeball at the graph. So when x equals 0, y is right here, right? It's -3. When x equal 3, what happened? When x equal 3, 3 is right here. You look up to the graph y equal 3, right? Or you can plug into the equation, right? So plug 3 for x, 2 times 3 is 6, 6 minus 3 is 3. So y is 3. Or when x equal -1, y equal -5, right? And etc. You can just plug in a bunch of points. But my point is that for every x, I have one y. So that means I don't have x. That means x is not repeated, right? So, so here, as you can see, as you can see, the vertical line test, so what do I say? I say, the vertical line test cuts the graph at most 1, the VLT, short for vertical line test, cut the graph at most once, right? At most once. Then the relation is a function. Then it is a function. If the vertical line test cuts the graph twice, more than once, right? We're gonna cut the graph twice or more, and it's not a function. For example, go back up to this example. If I draw a vertical line test here, pick any vertical line. Somebody can draw on the left, somebody else can draw on the right, right? As long as when you draw it, you only cut the graph at most once, right? Okay, all right. All right, so let's take a look at some examples. For example, number 1 is 1a is a function. Well, let's test with the vertical line test, right? So just arbitrary pick one vertical line test. Somebody else can draw it like this, right, to this point. Somebody can like to do it in the middle. It doesn't matter, right? As long as you cut the graph at most one. So when I pick the blue one, it's cut right here at most once. So I say, yes, it is a function. Right, so yes. What about the second one? Well, I arbitrarily draw a vertical line test, and it look like it's cut the graph at most at 2 times. So nope, not a function. Right? Not a function. Maybe I'll say yes, it is. It is a function here over here. I suggest you pause the video and then try this out on your own. Okay, so let's try it out. Twice, right? Cut it twice, so nope, not a function. And then what about the last one? You got it. It is a function, right? Yes, it is a function. I really hope my battery does not run out before I finish this. I did not bring it with me. All right, practice some more domain and range. Do you guys remember this? Last time I kind of teach you how to determine the domain and range from last lecture. All right, so this is a bit more, let's do some more practice. Okay, so I would suggest you use decimal to graph this, right? So just let me do the first one using decimal. So y equal 3x minus 1 using decimal. Y equal 3x minus 1 right there. Right, so take it away. No. Y equal, so 3x minus 1, 3x minus 1. Okay, I meant to put this away. Okay, so as you can see, let's talk about the domain first. Domain is all the x values, right? So you look from left to right. So from the left, if you go from the left, of course, this graph gonna go to the left and go to the right infinity, right? Infinitely. So from the left, what do I see? As I approaches outward to the left, I always see what, let me take a screenshot. If I go toward the left, well, I always find a value that satisfies the function, right? I can always hit the graph. So it looks like it's go from negative infinity, right? To what? What about the right? On the right side is that if I approach to the right, same thing, right? I can always touch the graph. Any value I pick on the x-axis, I can make the function define, right? I can touch that graph. So it looks like it go from negative infinity to positive infinity, right? Okay, delete that. Go back up here. So for y equal 3x minus 1, my domain is, why should delete? My domain is negative infinity to positive infinity. What about the range? What about the range? Well, let me go back to the graph a little bit. What about the range? Same thing, right? It's the same thing. So the range is all the y value. So again, you look from bottom to top, right? Always go smaller to larger. So bottom to top. As I go downward, I can always find a value that satisfies the function, right? I can always touch the black graph. I wish I could have a better color for that line. So that means the range, it looks like it's go from negative infinity to what? Same thing, right? If I go upward to infinity, I can always find a value that satisfies the function as well, right? So for the range, it's also go from negative infinity to positive infinity. I don't need this, delete this. So same thing for the range, negative infinity to positive infinity. Now, if you notice that y equal 3x minus 1, this is a linear. This one is a linear function. All linear functions have the domain and range in all real number is always negative infinity to positive infinity. Okay, so any linear function, if I in the form y equal mx plus b, it has the same domain. All right, for the second one, again, you can use the decimal, but I already know what it is, so I'm just gonna roughly sketch it for you. On the exam, I will give you the graph. You don't have to graph it yourself, right? So that is y equal x squared. It definitely a function, right? Because it's past the vertical line test. What do you think about the domain? Oops, making me nervous. The domain is, if I go outward from the left, I can always find a value that satisfies the function, right? So the domain is from the left it looks like it's go from negative infinity to what? To positive infinity, right? Because I go outward to the right, I can always find a x value that satisfies the function. I can always touch the graph if I project it upward like that. Okay. What about the range? Again, range is your y values. You look from bottom up, right? From the bottom, what does it start? Well, it starts at 0, right? So it's going to start at 0. So the range is from 0. 0 is included. So we're going to use the bracket and go to, what is the height? If I go upward, what happened? If I go upward, I can always I still can always find a value from the y-axis that satisfies the function, right? I can always touch that red graph all the way to infinity, right? So the range will be from 0 to infinity. We did this before, okay? Number 3, y equal x squared plus 4. Make it a little darker so it saves some energy. So a graph look like this. It's the same thing as y equal x squared. It just move upward for you, move up 4 unit. So here is 4. Right, there's that little intersection right there is 4. So the domain is the same as y equal x squared, right? Is go from negative infinity to positive infinity. The same explanation. What about the range? Maybe you pause me a little bit and then think about it. Right? Top to bottom. I'm sorry, bottom to top. So bottom start at 4 to the top is infinity. Number 4, y equal x cubed. Y equal x cubed looks like this. It looks like a railroad track. Oops, I meant red. So what do you think? What is the, maybe I'll do like, maybe better. Yeah, like that. What do you think? What about the domain? The domain, if I go outward to the left, outward to the left, I still can find what? If you down, just do the thing that I do a little arrow, right? You can always find a x value that satisfies that function, right? You can always find that, project the x value to the graph. So the domain is negative infinity to, same thing to the right, to positive infinity, right? And the range is same thing, right? It's look like it's go from negative infinity to positive infinity. What about y equal absolute value of x plus 4? Again, use your decimal to grab this. This is gonna move to the left 4 unit. So by the way, y equal absolute value of x is a V-shaped graph, like a shark T. Plus 4, so you move the left to the 4. I'll show you how to shift function later, but not now, right? Now I just use decimal. Okay, so, all right, what do you think? What is the domain and the range? Domain on the x-axis. Again, you can always find a value. If you go from the left, you can always find a value that touches that red graph, right? So negative infinity, the domain is negative infinity to positive infinity, right? And the range, well, it starts from where? Don't tell me it's 4. Remember, the range is the y values, right? So start from 0, right? Start from 0. Go to infinity. All right, so now the second part is read information from the graph of a function. I'm gonna give you a graph and I'm gonna ask you a bunch of questions. I would like you to look at the graph to answer the question. That's all it is, right? So for example, a 5f of y. By the way, the graph here is the solid black one. Okay. 5f of 0. What does that mean? What is 0 stand for? Is it represent x or represent y? That's right, represent x, right? So that's your x. So that means when x is equal to 0, what is y? So this mean when x equals 0, what is y? Remember, f of x is y, the same notation, right? It's the same, it means the same thing. You can look at the graph. When x equals 0, so when x equals 0, 0 right here, what is the height? Remember, y is your height, x is your width. When x equals 0, the height is, it looked like 4, right? It looked like 4. So 4. When x equals 0, y is 4. So f of 0 is equal 4. Let me give you another one. What about say A-ish? What about f of 4? Can you tell me what is the height when x equal 4? Well, when x equal 4, 4 is right here. There's no height, right? The function is right as 4. So when x equal 4, height is 0. So f of 4 equals 0. I hope you got the gist now. What about B? Find the value of x when f of x equals 0. So now it's backward. In part A, they give you x and they want you to find y. For part B, they give you y, right? Because f of x is y and they say y is 0. What is x? Find the value of x, right? So when y equals 0, I mean there's no height. So when it's no height, what is the x values that correspond to the y value that equals 0? I see it's here and I see it's here. Right? So add -4 and 4. So at x equal -4 and x equal 4, y is 0. Erase that. Okay. Find the x-intercept. Find the x-intercept. So x-intercept is where the function cut the x-axis, right? It's cut the x-axis right here and right here. Right. So at so x-intercept is what? Now I want you to write it in point. Okay, so -4. Maybe I'll use red. -4, 0. Right? Because when x equals -4, y equals 0, and then 4, 0. Now if you put like x equal -4, x equal 4, like that, I'm kind of not satisfied because I want points, not just coordinates, right? So at x equal -4, y 0. At x equal 4, y is also 0. Right? Okay. What about the y-intercept? Y-intercept is where the function cut the y-axis, right? So as you can eyeball it, it's right here, right? That's right there, right there. Right here, right? So what is that? What is that point? Well, we know the y value is 4, but what is the x value? 0, right? 0, 4. Find the domain, write interval notation. The domain again on the x is going to be the x-axis. So from left to right, it looks like to me, it start from -4 to 4, right? Of course, -4 and 4 included. What about the range? From bottom top, it start from 0, right? Because it start right here. Height start right there. Go to 4, right? So 0, of course 0 included and 4 included as well. Oh, I meant to give you one more. Oh, how come it's... Okay, all right. I thought there's one more that I asked you to do it yourself. I guess not. All right, I think that's it. All right. Thank you for being flexible with me and good luck.